Hello everyone, Sean Metzine here, and today we're going over denial of service attack, what it is and how it works. So the first thing I'll show you is distributed denial of service. So the way this works is we'll take the example of a web server being attacked. Okay, so pretty much you get, let's say, a web server here, www server, okay, and from here an attacker wants to bring down this server. Now what happens is that these servers are on they're on links to the internet, of course, right? So for instance, let's say that this guy is on a 1 gigabit connection, 1 gigabits per second. Now if an attacker wants to take this down with a denial of service attack, what his goal is to do is to flood the connection with enough traffic to saturate this link so no legitimate traffic can get to the server. So what happens here is that an attacker will have some servers possibly off of a botnet, which is a bunch of zombie machines that have software on there to flood, either to ping or to send a bunch of requests to the server to saturate the link. So what this would look like is the attacker's network may have hundreds of these little machines, desktop PCs for instance, like home desktop PCs that have been compromised, or they have some viruses and stuff like that. So then what happens is the attacker, usually these zombie machines will talk to a IRC server, internet relay chat. So these these desktops are all talking to the IRC master controller. The attacker has access to the master controller. Okay, so then from IRC talking down to these clients, we can tell these servers to start, for instance, on a regular attack, just to flood this traffic with pings, for instance, ICMP pings. So we send it to this link, okay, and as long as the traffic I'm able to generate exceeds 1 gigabits per second, then this server is going to be unreachable. Okay, because there won't be enough traffic for legitimate traffic. So you have a user here that legitimately wants to access this server. There'll be no access because this link is saturated and won't be able to process this user's request. Now that is one scenario. Okay, so we'll do ICMP, for instance, an ICMP ping, where now there's two transactions. One, if I'm pinging all these machines are going to send a request. Okay. Request, and then this server will have to come back with a response. Okay. Now, the problem with this is, yes, we've saturated this link in both directions, okay, but this is going to see if now this is going to send all this traffic back to these machines, okay, which is not a problem for the attacker because the goal has already been set. Now that would be an ICMP being TCP protocol, okay. It requires a response, so you're going to get two directional traffic. How about if we eliminated ICMP, okay, and we use a different method? So a new method now is, instead of doing ICMP pings and stuff like that, there's another method of, for instance, DNS amplification. What's that? Okay, so we'll remove this. Okay, same deal. A web server, www, 1 gig link. I got a bunch of zombie machines here. Now, another issue is that along with compromised machines, okay, we have servers out on the internet that are also compromised or they're misconfigured. Okay, one of them are DNS servers. So got a couple DNS servers here. Okay. Just for illustration purposes, we have DNS servers, 3 of them. Now, these DNS servers do not have a filtering enabled where we have any client can do queries against them, or rate limiting, so queries from, let's say, desktop machines can query them as many times as they want, as often as they want. Then what happens is this. Now, when you want to query a DNS server, you can do something called an NS lookup. Okay, now NS lookup, these aren't actual values. You can look them up online. But an NS lookup query may be 6 kilobytes. Okay, 6 KB. Now, the response to that is going to be much greater, because if you request the DNS server to respond with all of the records that it knows, that response is going to be more, because there's more data to respond with. So that data may be 10, 20, maybe even 30 KB. Okay, because the fact of the matter is there's more data to respond. So obviously, like going back, there's going to be more of a response, more data. Now, this is called amplification, because I've essentially amplified my response by more than tripled or even quadrupled the amount of data I sent, I got back. And since DNS runs on UDP, okay, a big problem with UDP is that there's no handshake, and there's trust in there, and on top of that, you can spoof your source address. So what happens here is that I'm gonna get my clients that have taken over, and I will say, okay, now do a DNS query from these machines, okay, to these DNS servers, okay, and then do an NS lookup, spoof the source address. So let's say this guy's IP is 1.1.1.1, okay, so I'm going to send the request from these machines with the source address 1.1.1.1. The compromised or misconfigured DNS servers will respond, instead of responding to the clients here, the source address has been spoofed, so it's actually going to respond to this. So that's how another DNS that's how another DDoS, I would say, another DDoS technique would be DNS amplification, as I just explained. So that's another way of DDoS. Okay. Now, another DDoS attack so let me just clear the board here. Okay. Another DDoS attack is not to saturate the link per se. Now, what could happen is, for instance, let's say this server is running Apache. Well, it most likely is, or IIS or something like that. Now, I can have my same machines run what's known as a slow RS attack. So we're going to attack Apache rather than the link. So what we're going to do is tie up the server's resources by sending, for instance, just HTTP GET requests, okay? But send them, so we're not going to flood the link, we're just going to tie up the CPU resources of the server. Now that would be another misconfiguration, because there's ways of blocking on the Apache server. You can do things like mod security. or mod evasive to help out with this. But assuming that this doesn't have that, these clients can now do the HTTP GET against this server and tie up its resources. Say that this was not a web server. Okay, another DDoS attack that can happen is against, for instance, something like a SIP server. Okay, so say that this was just a SIP server. Okay, what these guys can do is, instead of tying up the link, we'll tie up the server by doing SIP invite. Okay, so what happens is that we're going to send a bunch of SIP invite packets to the SIP server and make it believe that there's calls that are being processed or calls coming in, so we can tie it up that way. That's another form of DDoS. There's also other forms of DDoS, just like that. So there's many types of DDoS. There's many types of DDoS type techniques. They're all kind of they all have their own purpose, and they all kind of have their own way of doing it. But at the end, the end goal is to make sure that this server either becomes unreachable or is so overloaded that the performance is really bad. So now the problem with DDoS is that there's not much way of preventing it other than putting on more servers or increasing your bandwidth. There are a couple of products out there that can help you. So for instance, we'll go back to our web server type deployment or scenario. Okay, what can happen is this. You can get a hold of, for instance, SourceFire. Okay. Now, what SourceFire does is we'll break into this link. Okay. When clients request this web server, the infrastructure goes to cloud source. Or sorry, SourceFire. Okay. Goes to their infrastructure and then back to the server. Now, in the event of a DDoS, you enable this service, or hopefully you already have it, and this traffic goes through the SourceFire's infrastructure, which holds hundreds and hundreds and hundreds of gigabits of traffic. And then they're able to filter down requests or rate limit the request so that your server is pretty much reachable only because the traffic is not overloading your circuit. So that's one. Another one too is, in the case of a DDoS, okay, if you want to do it kind of yourself and you want to protect yourself, you can have a redundant 1 gigabit link. Okay, so you have 1 gig link here, and in the time of a DDoS, maybe you might be able to turn this on and kind of bond these two connections so you have more traffic. That won't fix the issue totally, because then all I gotta do, or the attacker gotta do, is generate more traffic so we can find more clients, or depending on how big this botnet is, might be much bigger, much more capable of just 2 gigabits per second. One thing, techniques never to use to protect yourself. If this is a web server and you have a domain name of test.com, okay, if the attacker is attacking your domain name test.com, one thing never to do is to change the IP address of your A record from 1.1.1.1 to 2.2.2.2. You may think that's going to help. It will not. The problem is that these clients are actually attacking the domain name. So once the DNS records update to 2.2.2.2, the attack happens again. So all you've done is knock down your site for 30 minutes to an hour while the DNS updates, and then it's going to get knocked down again once the traffic hits the server. Another thing not to do is to keep if this is not a web server, you can null route this IP address. So let's say this was the SIP traffic, SIP server again, okay, and it's 1.1.1.1. It would be acceptable at that point to scratch this 2.2.2.2, recommending not to go into the same subnet or same block of IP addressing. So if this is 1.1.1.1/29, try speaking with your ISP or something like that. So 2.2.2.2/29. Okay. The reason for that is that if the attacker is smart enough, he's going to check that this is /29, and then when one stops functioning, I would roll over to the next and see which one. So if you go 1.1.1.1 and then change this to .2, chances are that the attack is going to happen again. But if you're on a completely different subnet or a completely different block, chances are that that person behind the attack will have to do a lot more digging and give you a lot more time. Another thing you can do is, if it's a specific IP address, so let's say going back let's say 1.1.1.1, okay, you can null route this. Okay, you can null route this particular IP address to point to a black hole network, or to a router, one of your edge routers that have enough traffic to stop the amount of traffic coming into that one particular IP address. And that's all about denial of service attack. If you have any questions or comments, leave them in the description below. I'm going to try to start doing more live videos instead of just desktop recordings. And if you can let me know what you think, that'd be great. You can visit my site, SeanMancini.com, and thanks for watching. Have a good day.